Penguin Random House Audio presents Adaptable: How Your Unique Body Really Works and Why Our Biology Unites Us, by Herman Pontzer, Ph.D. Read for you by P.J. Oakland. For Janice, Clara, and Alex. Introduction. Disassembly required. We are all one, say the gurus. I might agree, but one what? Edward Abbey, a voice crying in the wilderness. In the vast Venn diagram of life experience, human dissection is that rare slice of real estate where the worlds of medical students and serial killers overlap. For one long New England autumn, my first semester of grad school, I deconstructed 160 pounds of person in my Harvard Medical School gross anatomy course. It was slippery and surreal work. Having grown up in a very do-it-yourself culture in rural Northwest Pennsylvania, I was comfortable at an early age handling knives, hammers, and other hand tools, but usually on wood or metal. Never on people. Using a hacksaw to carefully bisect a human head, damp, pale sawdust accumulating on the cheeks as the blade sunk down between the eyes, felt as though the universe had made a category error, like living out some absurd dream where your ant turns into a toothbrush or you find yourself driving a fish. Like most non-psychopaths, my classmates and I had all started the course hesitant to cut into a human body. On day one, with all of us gathered around the lead instructor as he demonstrated the first sweeping scalpel incision down the middle of a cadaver's chest, a student collapsed in a stress-induced seizure. I was an interloper, one of only a few in the class with no plans of becoming a doctor, and I expected some eager medical student, there is no other kind, to jump into action. Looks of alarm bounced around the room, but no one stepped forward. Seizure care isn't covered on the MCAT. I had spent the previous few years working on an ambulance crew, and so I went to work, pulling her out from under the table, turning her on her side, keeping her head from banging on the floor. I didn't know her medical history and was worried she might need serious medical attention. As she came to, trying to piece things together, I told her she'd had a seizure. "Yeah, that happens," she said, a bit grumpy. Then she got up, dusted herself off, and asked what she missed. It turned out she was an interloper as well, an MIT biomedical engineering student taking the class to understand the inner world her inventions would someday inhabit. The seizures were a stress response she had learned to live with. We became dissecting partners. People can adapt to just about anything. By the second week, the class settled into a rhythm, comfortable with the unglamorous work of disassembling humans. After a couple hours of lecture previewing the structures we'd be excavating, 50 first-year med students and a handful of biomedical engineers or biologists like myself would tramp upstairs to the dissecting theater, where a dozen bodies lay heavy and cold, zipped into thick black body bags on gleaming steel tables. Teams would assemble, donning white coats and latex gloves, 4 students per corpse. Over small talk, we'd unzip our cadaver's plastic cocoon and open our black pleather pouches of stainless steel dissecting tools, turn the greasy pages of Grant's Dissector to the day's menu, and dig in. Our captain on this inner voyage was the unflappable Farish Jenkins, Ph.D., a brilliant biologist and paleontologist famous for his work on ancient vertebrates' transition from sea to land and the evolution of mammals. Dressed impeccably in a starched shirt and tweed suit, his lectures had the urgency of a World War II newsreel. Farish would march us through every duct and vessel, the human body rendered in his impeccable hand through increasingly detailed, multicolor chalkboard illustrations. He was as well versed in the geography of the human body as he was gleefully eccentric. The lecture on gait, another one of his specialties, involved him clomping around the room with a wooden peg leg of his own design, reciting descriptions of Captain Ahab from Moby Dick. It was no accident that the lead instructor in Harvard's premier human anatomy course was an evolutionary biologist. An evolutionary perspective is essential for making sense of the human body. Farish's encyclopedic understanding of vertebrate evolution infused the course, illuminating the arcane and seemingly arbitrary details of our anatomy. It's nonsensical that lungs and stomach should develop from the same group of cells in an embryo, but obvious once you know how lungs evolved from swim bladders, outgrowths of the fish digestive system. The other instructors were an all-star cast of doctors, biomedical engineers, and experts in the art of dissecting humans. Even with all this powerhouse instruction, most weeks, if not most days, found my fellow students and I adrift, poking about our cadavers in a fruitless search for the structures we were meant to find. The web of nerves spraying out from the base of the neck to control the arm and fingers, the delicate weave of muscle and connective tissue in the pelvic floor. Sometimes things were precisely as depicted in Farish's drawings and our textbooks, but often they were not. These weren't minor anatomical details that could safely be ignored. These were critical structures, like the branching vessels that leave the descending aorta to feed the abdominal organs, or the vagus nerve that controls heart rate. It was stress-induced stimulation of the vagus nerve that occasionally sent my dissecting partner into a seizure. Roving instructors were kept busy each afternoon, moving from table to table, hunting down lost structures for flummoxed students. All of this perplexing variation was the point. People who donate their bodies to science skew white, wealthy, and old. And yet, hidden within the seemingly homogeneous slice of humanity laid out on our dissection tables was a surprising amount of biological diversity, individual anatomies we'd never find in our textbooks. And this was just the variation we could see with our naked eyes and amateur dissecting skills. More diversity lay unseen beneath the surface, within the tissues, deep inside the cells themselves, down to their DNA. All the illustrations and Grant's dissector diagrams were a convenient fiction. There is no textbook human. When these people were alive, their bodies in motion, these differences multiplied into the complex physiologies that made each person unique. High blood pressure, a fondness for ice cream, deeply felt introversion, a lifelong struggle with the bathroom scale, a knack for distance running. Fragments of these stories could be pieced together from telltale clues. An implanted pacemaker discovered next to the heart, an artificial hip, limbs lean and muscular or sagging with fat. I suppose it shouldn't have been a surprise. Our differences are obvious even on the surface. Why should our insides be any less diverse? Any course attempting to navigate the entirety of the human body in one semester is forced to balance all this variation against the seemingly contradictory reality that we're also all alike. We've each got a brain in our head, a heart in our chest, and a digestive tract running end to end. The textbook illustrators play the odds. For any particular piece of the body, most people look pretty similar. Chances are good that your vagus nerve travels the textbook route, even if the probability that every part of you matches the diagram is essentially zero. And much of the variation we experience in our daily lives, including the health issues the medical students would encounter as doctors, comes from subtle differences in how our
Sample complete. Ready to continue?